Right, in this video we do another example of finding an exponential function formula from some given data. I think we can see here on the left-hand side, this is our data that's been given to us. And what we're trying to find is trying to find y as a function of t, and we're trying to find an exponential function that fits this data that is of this particular form. A constant times a base b to a power t. Okay, what we're noticing here is that there's data. You notice that the time spacing, we can think of t as time, right? And we can see that the spacing of our time is every 1 second, 1 hour, 1 minute, right? We've got some data that's spaced out. And we can think of y, you can think of y as a count. You can think of y as counting money, or you can think of y as counting the number of bacteria. You can think of y as counting the number of infected individuals, right? This is a count of some process that is happening exponentially. How do we know this problem is exponential? How do we know that y is actually an exponential function of t? And we can see that that is happening because if we look at our ratio of y values, notice that 22 divided by 44, that is equal to a half. And if we look at this other ratio of values, 11 divided by 22 is a half. So you can see that we have a constant ratio of all of our y values is a half. And so we are seeing that these are constant, I should say this, it is the same constant, 0.5, and therefore it is possible for us to find a function of an exponential form. Okay, now let's go through and you can pick any two of the data points, any two consecutive data points. I always think it's helpful to choose the first two. The reason I'm doing that is because one of the times includes 0 and the y value, right? This is the initial time and this is the initial count of y's. And then maybe we can choose our first time to be 1, and then 22 is our first y value. Okay, we can see what happens in this case, that when you take your first data point, plug it into the function, y evaluated at the first time, the 0th time, that's times 0. Well, if you put 0 into this function, you get c times b to the 0. B to the 0 is 1. But we also know that y at times 0 is y0, which happens to be 44. So this tells us that our constant is always the initial value, the initial time value, the initial count of what we have. So at this point, we can say that our function y of t is equal to 44 times some number b to the t. And we can continue on to the next step by finding the other data point and using these values to find the base b. So you'll notice that when we take our function that we know and put in one time unit into it, we will get 4 times 44 to the b to the first power. B to the first power is equal to 22. And we are getting, let me see, this implies, b is b. B to the first is b, so we don't have to do anything except solve for b by dividing the two values. Now we knew here that 22 over 24 was the ratio that we just found at the beginning of the problem, constant ratio, and that's equal to a half. So we now know that the function, exponential function that fits this data is 44 multiplied by the base, which is a half, to the power t. Okay, and if you were to check your answer, right, you could use 44 multiplied by 1/2 to the time parameter t, right? And then copy that formula down, and you should see all of the same values, that this exponential function goes exactly through all the given data. So the y value that we get from our data matches the y value that we're getting from our formula. Okay, and you might notice that, for example, right, notice that when t is equal to 3, right, we are getting, this implies from our formula that 44 times 1/2 to the third power, that's 44, 1/2 to the third power is 1/8. If you were to compute 44 over 8 in your calculator, that should come out to be 44 divided by 8. Let's put an equal sign on that. That is the 5.5 value. Okay, so this formula right here is the formula that we were looking for, the exponential function that best fits this data. And not only is it a best fit, this formula is an exact fit because the ratios of the consecutive values was a constant. So ends this video.